With problem number 7, we have a very similar scenario, and yet there is a different aspect to this problem, and that is we have a vertical asymptote when x is equal to -1. So we're going to continue in much the same way. We'll start with our original function. F of x is 1 over x plus 1 quantity squared, and I'll write that just as x plus 1 to the -2nd. Find our first derivative. That is -2 times x plus 1 to the -3rd. And we can tell from this right away that we get -2 over x plus 1 to the 3rd. A rational function is 0 when its numerator is 0. And so there is no horizontal tangent here because the derivative is never 0. But there is one point where the derivative doesn't exist. And that's not a critical number because it's not a point on the original graph, but it is a vertical tangent there, vertical asymptote, I should say. And it is going to affect how we set up our sign chart. So in this particular case, there are no critical numbers, but there is a vertical asymptote, which I usually use a dashed line to represent at x equals -1, and it's still going to break up the x-axis. So we want to test -2 and a 0 over here. Again, we should note that we are working with f prime of x, and we're going to test our derivative. And here's our derivative right here. We're just going to plug in -2. When we plug in -2, we'll get -1 in the denominator to the 3rd power is still -1. Negative over negative is positive. And so you can see we most definitely have a positive slope everywhere to the left of -1. Then plugging in 0, we're going to get +1 there. 1 to the 3rd is 1. -2 over 1 is going to be negative. And so we end up with positive and negative, but because this is not a critical number, -1 is not a critical number, we don't have a relative max or min there. It is a vertical asymptote, so you have to be really careful about that. And we say it's increasing from -infinity up to -1, and it is decreasing from -1 to +infinity. And so that's all we really needed to do here, but I wanted to show you how to work with the vertical asymptotes. And again, we can see clearly we have negative slopes at every point to the right of -1. And so that is going to do it for this section. You should try number 8 on your own to make sure that you get this same idea here.